the unit, it's easy to take to the laboratory small piece of stone and make some, for example, compressive testing. So this first parameter consider this conservation state and mechanical properties, and the three outcomes: not fulfilled, NF, partially fulfilled, and fulfilled. It depends on the type of the bricks. For example, unfired bricks is not fulfilled, or sandstone is partially fulfilled, or hard stone on opposite are fulfilled. Okay, so we start to give a classification. We start to classify the material, stone, bricks, and so on, and we give an outcome for this parameter. So example. So if you have, for example, hollow, that is common in the 30s, 1930s in Italy, was this big hollow bricks. Okay, of course, this is not fulfilled. Or if you have a tough masonry or the sandstone masonry, this is partially fulfilled. On opposite, if you have a hard stone masonry, the outcome of this parameter will be fulfilled. And this is the first parameter. The second parameter that we have considered takes into consideration the dimensions of the elements. So this is also important because the dimension of the elements has an influence also on the shear. For example, look here at the bonding pattern. If you have the bricks placed like all headers, the diagonal cracks typical of an earthquake is easier to occur because it will develop only in the mortar joints. On opposite, if you look at this wall on the bottom, where you have a different bonding pattern, you see that some bricks need to be cracked. So also the bonding pattern has a critical influence effect on the mechanical behavior, on the structural response of the building. Look at this. Because masonry has zero tensile strength, we know when we do our model, a lot of us don't think too much when they put zero tensile strength, right? So it means that there is not, lateral distribution of the load because there is no tensile strength. So if you have a vertical load, the distribution of the load depends mainly only on the dimension of the elements. Because only if you have a tensile strength, it can distribute 45 degrees like it is, for example, in concrete structure, in reinforced concrete structure. So the dimensions of the elements, it's something also very important to be considered from the structural point of view. Okay, so example, how real application. So when is not fulfilled the outcome, or when you have, for example, rounded stones or pebble stones, or you have barely cut stone is partially fulfilled, and of course when you have perfectly cut stone, the outcome of this second parameter will be fulfilled. The third parameter that we have considered in this structural assessment is the shape of the elements. So you can see that it can be perfectly barely cut or pebbles. Okay, so this is another thing that must be considered. Of course, brickwork will be always, the outcome will be always fulfilled because bricks are always, let's say, with a parallelepiped shape. Okay, so you consider all these parameters and basically you give an outcome of the three possible outcomes. For example, so if you have uncut or barely cut stone is not fulfilled, here is partially fulfilled, and here is fulfilled. And this is the third. Now we consider also as another critical parameter the level of connections between wall leaves, because we know that in many situations walls are made of a double leaf wall, and it's very important to assess, especially for the out of plane behavior, if the leaves making up a wall are well connected or not. So, you know, if the cross section is visible, and this is not always the situation, but if the cross section is visible, if you consider 1 meter of a wall, you can consider the red line passing only through the mortar joints, and you can measure how long is this red line. Of course, if the connection is weak, this red line is almost a vertical line. On opposite, if the connection is good, the red line has a zigzag shape, right? So it's longer. So if the cross section is visible and you can measure how long is the red line. You may have not fulfilled, partially fulfilled, and fulfilled outcomes, depending how long is this red line. So the problem is that in many situations, the cross section is not visible. So we have also another part of this table when the cross section is not visible. So you try to estimate the number of headers, that is transversal stones, in your wall. So if you have a systematic presence of headers, that of course this will be fulfilled. Then if you have no headers, the outcome of this measure will be fulfilled. So basically this is the situation, right? So for example, here you have a brick wall. If you have a very small number of headers, that are these black bricks here, the outcome will be not fulfilled. If you have a low number means about 3 or 4 per square meter. Okay, 3 or 4 headers per square meter. The outcome will be partially fulfilled. And on opposite, if you have a systematic presence of headers, like in a real well done wall, the outcome will be for the headers fulfilled. It's a very important, the presence of headers, especially for the out of plane behavior of a wall, right? So the out of plane behavior of a wall, to have a rigid behavior, rigid response of the wall, is critical that multi-leaf walls need to have a large number of headers. That's the problem, basically. Okay, so if you have an headers, the behavior is the first on the left. If you do not have headers in a multi-leaf wall, basically the response of the wall will be the one on the right. That will be very weak, of course. The fifth parameter, taking into account the horizontality of the bed joints. We know all of us knows that when we put bricks and stone to construct a wall, we do this using horizontal courses. But this was not the case in the past for low quality masonry. So this is the ideal situation. So we want our walls to have horizontal bed joints. Okay, but if we look to real structures, we may have the ideal situation where the outcome is fulfilled, and then we may have also situation where the horizontality is not continuous. So is it continuous for not for the full length of the wall? Is continuous for 1 meter and then it's not anymore? Or we have this very weak situation on the bottom right where the horizontality is interrupted every half a meter, every 20 centimeter. And we say that the outcome of this parameter is not fulfilled. This is the fifth parameter to assess the structural response of the wood. And the sixth parameter is the vertical head joints. On opposite, the head joints must be scattered, it must be staggered. So we see that these head joints must be halfway of the the width of the brick or the stone is over or under. This is the ideal situation. So all the vertical, the head joints must be staggered. If we look at historic masonry, this is not always what we can see. So if we look at the historic masonry, we may have an ideal situation where the vertical joints are staggered, but also a bad on opposite situation where the head joints are not staggered, they are aligned over a vertical direction. And this, of course, give a negative, of course, effect, contribution to the structural response of the wall. So we have fulfilled, again, partially fulfilled outcome when it's in between, and you can look at here for details when it's partially and when it's fulfilled and not fulfilled. So we again here, if we want to measure, as an engineers, we like numbers sometimes. Again, we can do something similar with the red line we have done on the cross section before. We can consider, for example, 1 meter of a wall, 1 meter 8 of a wall, and passing only through the mortar joint, we can measure how long is this red line. Of course, longer it is, more staggered are the head joints. So basically, we say that the outcome will be fulfilled when this line is longer than 1.6 meter. So for a height of 1 meter, this line is 1.6. And if it's smaller than 1.4, the outcome will be not fulfilled. Just to have an idea of the head joints, how staggered are the head joints. And of course, the last parameter is the mortar. That is critical importance. So of course, we remember basically in historic construction, the lime is always, the mortar is always a lime. We don't have cement because cement has been introduced in the 40s, in the 30s last century. So the only difference that we may have aerial lime or we have hydraulic lime. Of course, hydraulic lime typically has a strength that is minimum 2 times or 3 times bigger, larger than aerial lime. We know the reason because we know what is the chemical, reaction in aerial lime and hydraulic lime. We can find this even from the color of the mortar. We know that hydraulic lime typically is brown or pozzolanic color. That is possible to do. Or we can do even chemical analysis to understand this. So, and of course, here we have an outcome of the analysis of the mortar, not fulfilled, partially fulfilled, and fulfilled. So basically, we have calibrated based on over 100 on-site testing in the last 25 years. We have proposed a formulation that takes into account the 7 parameters. Okay, so we have a numerical value for the 7 parameters. These numerical values has been calibrated, and at the end we will have an index, a number that is a measure equality index. So we have this parameter depends on the loading condition of the wall. So if we want to estimate, for example, the compressive strength, or we want to estimate the shear strength, these 7 parameters has a different value. So basically, for example, what I said, that is, this wall has the same compressive strength, but has different shear strength. So the compressive strength is the same, the shear strength is very different one to the other. Because of this, you see the cracking is all only in the mortar joints. So it's very easy to take to failure in shear this kind of wall. And also we have 2 different loading conditions that is typical for historic masonry. It can be in plane loading or out of plane. So we have different numerical value for the 7 parameters, depending if we are considering compressive strength or in plane loading or out of plane loading. So this is what we propose, the 7 for each parameter. We are giving the 7 numerical values, and depending if it's not fulfilled, partially fulfilled or fulfilled. And basically, by doing this, at the end of the day, you can have a numerical value of the masonry quality index. So here, you using this formula, you get a number, final number, that's the masonry quality index. What you can do with this number? We propose some graphs to move from the quality index to the mechanical properties you are looking for. So here you calculate your masonry quality value with the method we have showed before. So you put your number on this horizontal axis, and then you go here, you go on the cube, and for example, you have an estimation of the shear strength. Okay, so without doing a test, but doing, let's say, a very engineering oriented analysis. Why do we have 2 cubes? Because it's a range, of course. We cannot give a very one value, but we give a lower bound and upper bound value. And by doing this, we can estimate, and we have a graph for the shear modulus, we have a graph for the Young modulus, we have a graph for the compressive strength. I'm not showing because are similar to this. So for example, the method is, for example, you have this masonry. What are the 7 parameters? So joint, horizontality, conservation state, and so on. So you put the value in the section, and you calculate 3 different values of the quality index, depending if it's vertical loading, out of plane loading, in plane loading, and then you have a range of the mechanical properties you are looking for. Maybe you can use these mechanical properties for a model, for a numerical model. Okay, so you have, for example, here you have a report of the stone, and at the end you have an estimation. So here again, for this type of masonry, again, you have three values. You see the outcome for each parameter, fulfilled, not fulfilled, and so on. At the end, you have this number, that is compressive strength, shear modulus, and shear strength, and so on. We have done this on a large number of buildings, and we have calibrated this number based on a large number of real tests, mechanical tests that we perform on site. And so the last 5 minutes, if I have, I would like to talk about a particular failure of masonry that a lot of engineers doesn't consider this as a proper failure for masonry. So what we noted in the 2016 earthquake, that a lot of masonry construction did not fail by macro elements. As an engineer, the most part of our numerical models are based on the method of macro elements. But a lot of construction, of low quality construction on the countryside, collapsed because of disgregation. Okay, so how can we adapt the masonry quality index to these types of really non-engineering material? We cannot say this is a material. It doesn't have any, any method to make a serious analysis of such weak construction. Unfortunately, such weak constructions are common in the countryside, in the poor area on the mountains in many parts of Europe, and also in many parts of Asia or Africa. So look at this video. So look at that was 2003 earthquake. So look at the failures. You see the macro element is forming with this diagonal crack. Okay, that's nice. Look, so it's forming. It start. You see the wall on the left. It start to rocking, to overturn on the left. Look again. You see the mechanism. So here we have the mechanism. We have the macro element of the facade that is overturning. But at one moment, the mechanism stopped developing because everything disgregated. Everything disgregated without a clear macro elements analysis. So these anticipate the analysis and the failure that we are expected from our models. When we do our models, there are many commercial software on the market, all based on microelement. So these methods can be very dangerous to be used, dangerous in a way that give an overestimation of the seismic capacity of a building, because the quality of the masonry is so low that microelement cannot develop. So these types of analysis are typical in engineering, structural engineering, in seismic engineering, earthquake engineering, are not appropriate. So basically, we have adapted our masonry quality index, and basically, we have noted, but more tests needs to be made, that when the masonry quality index basically is lower than 4, the real mechanism under an earthquake is not a macro elements mechanism, but is a disaggregation of the masonry. So you need to have in mind that the masonry quality index can be used also to understand what is the limit between a macro element method and disaggregation method. So, okay, I can stop here, and I'm happy to answer your question if you have, and thank you for your attention.
Okay, thank you very much, Professor Corradi. So we are waiting for the questions from the audience. If anyone has a question regarding to this interesting topic, which also in Albania is very of days. So nowadays we are actually dealing with such kind of problems. In many historical sites, we are having such problems with the walls, but in general, what they do is just demolish and build a new wall in such cases. So,
Yeah, if you have new masonry, everything is easier, of course, because new masonry, of course, you have better mechanical properties. So you may also use these traditional numerical models with the macro element. But if you want to deal with historic masonry, it's very important to understand when the failure mode, the expected failure mode is disaggregation.
yes,
Because when you have disaggregation, look at here, you see the instant when and there is no macro element here. There's only disgregation. Okay, so basically the mechanism is this one, you see. There is no macro element. So it's very difficult to make a numerical analysis with the method of kinematic chain. Basically, the microelement method is a kinematic chain method, right? Uh,
yeah.
so, uh, so
Actually,
really, it's very difficult.
the wall doesn't work as one piece.
Sorry?
In this case, the wall doesn't work as one piece.
Exactly, exactly. It's not multi-leaf. It's not rigid. It's it's something inconsistent. But to be honest, a big part, a big part of existing building stock, especially in the countryside, in Italy, but probably also in the Balkans where you are made with such weak material.
Yes, yes.
And structural engineers cannot use this sophisticated method to assess the seismic capacity of such weak construction
Yeah.
because you overestimate the capacity of the buildings.
Okay, thank you very much, Professor Corradi. Now,
Thank you.
Professor, okay, I think there is a question. There is another question.
Hello, Professor Corradi.
Hello.
So I really like your presentation. Thank you very much. And I would like to question, as you said, like the structural engineers nowadays are doing these advanced models and trying to capture the behavior of masonry. But you said that if we have this MQI very low, like up to 4, then we can't really capture it, basically.
Exactly. I mean, it's a critical information already. So a structural engineer, as a professional, if I need to deal with a building where I am expecting my building to collapse because of disaggregation, okay, so I know that this kind of numerical approach is incorrect, first thing. Okay, so I need to use a different solution that we can open a discussion what could be the solution, because it's not so easy to say what is the solution. On opposite, if the masonry quality index is bigger than 4, this method, the method of numerical method of macro elements, basically it can be a good solution because it can give us an indication of the capacity, of the failure mode, and so on. Okay, so the Masonry Quality Index, it can be very useful because it gives you an indication which failure mode is more likely to occur, and also it gives you an indication of the numerical properties. So by using such calibrated, of course, you may say it's calibrated on a small number of buildings, only about 100 buildings, using such tools and putting here on the horizontal axis the value of the Masonry quality. You may have a range of, for example, the shear strength.
Okay.
So it's very engineering oriented. So we look at the masonry from the point of view of an engineer with the mechanical properties of the material, head joint, vertical. You know, there is an engineer behind this method. We can discuss if it's effective or not, if the range is too large or not. But unfortunately, when we talk about masonry, and I go back to the first slide, it's very difficult to give an indication. Look at this building, this wall. Look how many challenging for an structural engineer, how many challenging things. So this is a vertical joint here. There is a stone masonry here, brick masonry here. It is really something that is difficult to transform into a numerical model, because we cannot model a single stone. Is a micro modeling. We need to a little bit find professional solutions that may be really, a tool to look forward to have an idea, So I believe that the Masonry Quality Index can be a useful tool because it's a good balance between the reality of the situation that is very difficult and the point of view of an engineer that likes to work with numbers and calculations.
For sure, yeah. And I also think that this opens another door. So if we see that this MQI is going to be below 4, maybe new constitutive models should be built.
Yes.
So we can count on this.
Yes, yes.
On properties.
Exactly, yes, yes.
Oh, thank you very much.
Yeah, thank you, welcome.
Thank you, Mirva, for your question. Thank you, Professor Corradi, for your presentation. Now we are going to start with the technical sessions, and Professor Bilgin will moderate the first session. Welcome, Professor Bilgin. The floor is yours. Thank you.
Thank you, Chairman. Good afternoon, ladies and gentlemen. I'd like to welcome you all to the first session of 4th International Balkans Conference on Challenges of Civil Engineering. Before starting our technical sessions, let me briefly mention about the time allocation for each presenter. So according to our timeline, we have 4 presenters in the first session, and each presenter has 15 minutes for the presentations, including questions and answers. So at the end of this session, we will have 1 hour lunch break. After that, at 2:30, we will continue with the second session, who will be moderated by Associated Professor Dr. Miriam Nidini. So I would like to open the first session by inviting the first presenter, Mr. Claudian Scrame, with his presentation entitled Earthquake Resistant Steels in Albania, the Seismic Microzonation Studies and Limit Condition in Emergency Integrated Approach. So the floor is yours, Mr. Claudian.
Thank you, Professor Bilgin. Thank you to everybody.
Okay.
I don't know if you can see my desktop.
Okay.
Yes.
Okay, that's perfect. So thank you to everybody. It's an honor for me to be here, and I would like to thank, first of all the colleagues of Epoca University, and my congratulations go to all of you for making such a beautiful and interesting conference in such a critical situation. And I'm Claudian Skame. I'm an engineering geologist with an experience, let's say, of several years in geohazards, especially on earthquake situations, so seismic hazards especially. And I'm here to show you some of the results that we obtained during research activity of 2 years that we have with our colleagues from CNR. And we studied 3 different cities here in Albania. And the perspective and, let's say, our goals were to make a seismic micronization studies of these cities and the limit conditions in emergency in a perspective of building earthquake resistant cities. So yeah, here are the papers that we have produced during this period. So if you are interested, I'll be happy to share them with you. And some of the results that we obtained and the maps that we obtained will be shown here. So the outline of the presentation, so it will be like, let's say in 5 steps. So we'll have the introduction, the brief introduction, the seismic resonation studies, limit conditions in emergency. I'll show you here 2 cases of Durrës and Gjirokastra and some future activities that we are going to do. So as everybody know, actually we have Albania, which is a very seismic active area. No, it's like a cracked glass with so many active faults that produce many earthquakes from the north to the south and from the east to the west. As you can see, we have many earthquakes. And turning back to the numbers, these are most of the important earthquakes that we have had with magnitude higher than 5. You will find here in blue. And with magnitude higher than 6, you will find here in red. So to see the numbers, we have in 114 years, 17 seismic events that have produced more than 407 victims, hundreds of thousands injured, and millions or hundreds of millions euros of damages actually. And one of those were even the earthquake of Durrës, with so many small earthquakes and 2 main events that we have in September and in November of 2019. So how can we deal with this situation? So how can we manage these disaster conditions that we have? I think that we are, there are 2 situations, the peace condition and the work condition. So the peace condition is before an earthquake occurs, the work condition is after the earthquake occurs. And during the earthquake, we cannot do too much. What we can do is the preparation that we have. So in these conditions, so right after the earthquake, as we are now, or right before an earthquake occurs, we have to make a mitigation. So hazard and vulnerability studies of seismic events actually. And the preparedness. So we have to prepare the civil, we have to prepare the professor and the university to get ready for the earthquake. And during the earthquake, the only thing that we can make is the response of that and the recovery, which is much more decision maker part. So what do we think? We think that seismic hazard mitigation and prevention actually can be organized in 3 main steps. So the seismic hazard at national and local level. Something has been done with identification of the seismic tectonic and seismic source zones and the identification of focal mechanisms. So we know actually where are the main active faults, as we know where are the main earthquakes that can occur and even the magnitude that they will have. What we do not have is a seismic microresonation studies. So we do not know for sure we do not know our territory. We don't know for sure where the main damages will be built and will be created actually. Even in a perspective of urban plan, the seismic resonation studies has to be crucial. Something has been done. In 1979, after the earthquake of Montenegro, there was a national plan and for seismic prevention. And right after this earthquake, there was the renewal of the national codes for design in 1989. But unfortunately, these are the only national codes that we still have, which are still in effect. Actually, we have no European codes implemented. And even with the new law of 45 of 2019, there is nothing said, and no one asked for the seismic resonations, which from our point of view is crucial and very important in these cities and in this country. And the third step will be the construction projection. Actually, the engineering, geological, and geophysical modeling of the subsoils of the 3D model is crucial and very important. And even the local seismic response has to be very, very interesting and important. So here in Albania, we have this situation. These are the only cities that have been studied. And these are the only cities that have the geological engineering map. But what they have only a small part, because if you can see the map of 1984, where these studies have been made, actually the cities in Albania, the Durrës, was like this. And this is the situation now in 2020. And this is how the coastal part has been changed. Even the city of Tirana, for example, our capital, has changed a lot. This is the situation that we have now. And even the city of Vlora, which has many, many problems with the phenomena of seismic amplification and liquefaction, for example. And this is the situation now. And during this study, we were able to even identify zones, for example, with stratigraphic, so seismic stratigraphic amplification that we have in these buildings here, or even earthquake-induced landslides that we have at Shkambika Valles, for example, during the earthquake of September 2019. And even the cases of liquefaction. We have many cases of liquefaction, and we can even individuate these areas. So I think that the seismic resonance studies are a process, a process that involves many, many figures. So it's a multidisciplinary study that actually will start with the GIS database that we made with the geological map, with a small geological in small scale and in big scale. So this is a 1 to 10,000 scale. Then we took the old seismic resonations map and digitalized that and inserted in these GIS databases, even the old existing bedrock map and the engineering geological map. And at this point, we made our new measurements. So we made 20 ambient vibration measurements, 2 mass survey, and 2 2D array measurements. And we put all together. After that, we were able to produce the frequency, the fundamental frequency map of Durrës. And based on that map, we were able to make the fundamental periods map of the Durrës, which is very important for the buildings and for the civil engineering. And after that, we were able to have an idea of the depth of the bedrock, so where the geological bedrock is, and of the thickness of the fine sediments that are right on the upper part of that, and which are crucial for the seismic amplification activities. And we did the same for the city of Gjirokastra. So we took all the existing map, we put it in the GIS databases, we produced the DEM and the slope map. And yeah, we made some new measurements, 25 ambient vibration, 6 2D array, and 6 months. Based on that, we were able to reproduce the microzonation map, the seismic microzonation map. As you can see, we have different areas here, which have a different response to the seismic events. In some cases, we will have the earthquake-induced landslides. In some cases, we will have the topographic amplification. In other, the stratigraphic amplification. And yeah, all these maps and all these studies has been made following the Italian guidelines. And we firmly recommend that the third study, so the third level of the seismic resonation study, has to be made for these cities, basing on the big ground acceleration that they have, which is very high. And the same situation is for Berat. It's a little bit different because we would have the topographic amplification in that case, especially to the most important and the most interesting and tourist part of Berat. But this is a study that we are still going ahead. And which is the most important part, and where the civil engineer can play a crucial role on that, is the preparedness, so the emergency response plan. And we think that the limit conditions emergency will be the solution. So everybody can remember this situation where people were going out from their buildings and houses and they didn't know where to go, just getting in the car, creating these situations which were very, very uncomfortable and even very dangerous. And from our perspective, the study made in conjunction of these two different approaches, we think that will be the solution of this condition. So the limit conditions emergency will be able to identify the buildings and areas that guarantee strategic function for the emergency, could identify the infrastructure for accessibility and connection with the territorial context, and could identify the structural elements and individual structural units that may interfere with the accessibility infrastructure. So to see what we actually did for the city of Durrës, as you can see, we were able to reproduce the emergency plan, if we can call it so. And if we make a zoom of that, you can see that we have, basing on our survey and our seismic resonation study, we were able to define the emergency area. We were able to define the structural blocks, which actually could block our paths. And this structural block will need your study, so the vulnerability, seismic vulnerability of these buildings. So we have to know for sure if this building could block our paths or could leave us go in emergency condition, and the strategic buildings where the soldier and the technical has to remain to organize all the activities that has to be made. And we did the same for Gjorokastra. As you can see, we have the same situations, so with the paths, with the structural blocks, and everything has been based on the seismic resonation study. So we think that this approach could orient the choice for new settlement, could define the eligible intervention in a given area, and could establish methods and priorities for intervention in urbanized area. Everything, as we are now in finishing these activities, everything would be uploaded as a web GIS, where young researcher, professionals, citizen, even institutions and university could have the access to the data and for their research activity, but this data could help even the decision maker and especially the Albanian Nation Civil Protection Agency to spread it up all around Albania. And yeah, if you can see, as you can see, we were a really multidisciplinary team. So there are engineering, geologists, geophysicists, architecture, computer science, GIS experts. So people of different fields could work together in these activities. So the take-home message for us will be a first level of seismic resonation studies that need and have to be done as fast as we can for all the country, so for all the cities of Albania. A third level of seismic resonations, as you saw, has to be made for the main municipalities of Albania, like Shkodra, Vlora, Durrës, Saranda, Tepelena, Korça, which are the most, the cities which are the biggest cities, but have a very high peak ground acceleration. So it means that in an earthquake, they would have a huge impact and a high intensity, so high damages. And the local seismic response, we recommend to be made for the strategic building. So for the universities, for hospitals, and for schools. This is a study that has to be done. And the seismic vulnerability of the buildings, this is your part. So this is a work for the civil engineer, but we firmly believe that we have to start with this process. Why not to make for all the buildings to know where the people are living and if these buildings are safe. And yeah, we recommend that this approach of LCE and seismic resonation could be the solutions of this condition. Another thing would be to build the National Committee for Predicting and Preventing Major Risk. And in the process, we think that the colleagues of Polytechnic University, together with the colleagues of Epoca University, could be crucial, and their knowledge would be very important. And if they can be supported from the Academy of Science, I think that we can give altogether a huge support to these activities and to these studies. And last but not least, I think that the only solution maybe would be to take part of these international activities and projects like Horizon Europe, IPA, and JRP. For example, as we did it with the colleagues of CNR, but we can even involve our private company, which has huge experience in these activities, especially in emergency. And me, as a national contact point for the climate change, environment, resource efficiency, and raw materials for Horizon 2020 and now for Horizon Europe, I'll be happy to collaborate with you and to find a way to write some project together and to try to do the best for our territory, but even to put and to do some active research that could be applied to the citizen. So I think that the time is now. I really want to thank you very much for this opportunity, and I'll be happy to have your email, your questions, and why not your contact to get together and to try to do the best. So, thank you very much.
Thank you, Mr. Skramer, for your nice presentation and sticking your time limit. We have time for one question. Do we have any question for Mr. Skramer? I don't see any question. Thank you very much for your presentation again.
Thank you.
So let me move on with our second presenter, Erdoğan Periku, with his presentation entitled Cementitious Grout Method Application on Tunnel Rock Bolts and its Effect on Boat and Load Carrying Capacity, a real-time pull-out test on Fan River Hydropower Plant Power Tunnels. Welcome, Mr. Periku. We have 15 minutes for your presentation as well as for questions and answers. The floor is yours, please.
Marcelo, and its effect on the boat and load carrying capacity. It is a real-scale pull-out test performed on the Fan River hydropower project tunnels. Me, together with engineer Dusha, have performed the site test, and Professor Luga has done the methodology and the test, the testing program of this paper. And engineer Shaperi has prepared and done all the laboratory tests. As we know, the tunneling is a growing industry in the construction sector, even in Albania, although it is relatively new. We are already doing some tunnels, and the easiest way, and let's say the cheapest one, especially for the short and middle length tunnels, is the blasting and drilling process. In the blasting process, as it is shown in the figure, that we know that the perimeter of the rock after the blasting, there will be created some cracks, and there is a possibility for the cracked part of the rock to be fall down. So we have to support these parts in a meaning, and the best way of doing, one of the best ways of doing that is inserting the rock bolts. And basically we transfer the load from the cracked, the fracturated rock to the sound rock. The nature of the load transfer in the rock bolts are mainly of three types. Depends on the three properties: the type of the bolt, the property of the cement or grout material, and the properties of the rock and the sound rock. So we use three types of rock bolts. The first one is the mechanically anchored one, which has a mechanical part in the ending, and then the bolt is fixed on that. The other one is the friction bolt. We insert a part of, let's say, steel or something that can be enlarged with a mechanism within the hole. And the last one that we are dealing with, and we have performed our experiment, is fully grouted rock bolt. So basically, this is the fully grouted rock bolt. It is composed of a steel rod, a plate, and a fixing nut on that. And the part here is the grouting that has gotten the cement grout. So the testing materials in this paper are rock bolts. For the ones that we have used, the fully grouted rock bolts. In case that it is not a cable, it is used a normal steel bar with the characteristics for our test with the yield capacity of 550 megapascal, the average one, and the relative extension of something about 20%. And our grout material has a compressive strength of 43 megapascal and a flexural strength of 6.67 megapascal. And the surrounding rock, basically the tunnel that we worked on was ultra basic by its base. Although they are expected to be the compressive strength to be more than 100 megapascal, the average of our material was 64.87 with a standard deviation of 11.2. So this is our experimental program. Here we have a pull-out cell, and here is the pressure pump which apply the load. In the pressure pump, we have two gauges. One is that measure the pressure, and another one that shows us the force. For this purpose, we have used only the force one, but both of them can be inserted. There is a place over here that the gauges can be inserted, and you can see either the force or the pressure that is applied. And this is a photo from the real test that is performed in the site. So this is the tunnel, and basically we have two types of rock bolts on it. The first one is the ones that are directed downwards, and the second one are the ones that are directed upwards. In our experiment, we think that we have to divide the upward rock bolts into two groups, because as the angle of inclination is increased, the performance of both is decreased. So basically the half of the tunnel is the same as the one that we have done. So we have grouped it we have divided it in three groups. The first group is totally downward rock bolt. The second group is upward rock bolt from the angle 0 to 30 degree, and the third group is also upward rock bolt from the angle 30 to 90 degree. Here are the rock bolts that I just explained. This is the upward directed one, and this is the downward directed one. So at the beginning of this experiment, we started with SN rock bolts, which are mainly known as post-mortar installed. And we saw that the difference between downward inclined and upward inclined bolts was so high. So we decided to change the application method of the grouting, and we went for post-grouted PG rock bolts. Which are shown in the figure here. For the upward inclined bolt, we have the grouting methodology like that. Let's say in both cases we have a grouting hose and a ventilation hose, and then we took the results for the two tested specimens. Let's say the SN rock bolts and the PG rock bolts. So these are our results. We went for, as was divided before, here we have a group. The first one is downward, the second one and the third one is upward inclined rock bolts. And as you see, for the downward one to the upward one, we have a decrease in the applied load for more than a half, let's say. And in the third group of the rock bolts, for all of them, we could not measure any displacement. So just the applied load and no displacement at all. We went direct to the failure of the element, and all the failure types, the structure, are due to grouting. Then we changed the application method, the grouting method. So we went from the SN rock bolts, that means the pre-mortar rock bolts, let's say, to the post-mortar or post-grout. And in this case, we have for the entire section of the tunnel similar results. The applied load when the bolt failed was increased a bit, but what is more important, the displacement is increased significantly. And even in this case, we have all the failure in the grout material. So we have done a comparison for the two types of the bolts that we have applied, the pre-mortar and the post-mortar, pre-grouting or post-grouting, and we see the difference between them. So in total, the increase in the load carry capacity goes to 148.88%, and the maximum displacement increases till 112.07%. And here are the detailed values of all the data that we have used for this test. So we came to the conclusion part, why this study is so important in our opinion. This is carried out in 144 rock bolts with a total length of 625 meters, which is, let's say, impossible to perform in laboratory or small and medium projects. Also, when we go to the tunnel construction, we take some pre-data and we are supposed to know that the ultimate strength capacity of the rock that are taken from the geological data or the boreholes that we do. On it, we are supposed that the ultra basic rocks to have an average compressive strength capacity of over 100 megapascal, but in our case, it was 64.87 megapascal. So it is important to have a real test on the rock material, as it is one of the main components that affect the failure. The entire pre-grouted rock bolts showed very low viewing capacities and almost no displacement. The ones that are inclined upwards have even smaller results, and this is due to improper grouting. And this method, we think that is improper in total. So when we change the grouting method from pre-grouting to post-grouting, the results were improved dramatically. We have the load is increased by 5.76% to 148.88%, and the maximum displacement value still 112 on 112.07. In all the tests that we have done, we have reached the conclusion that all the bolts have failed due to the grout. So this clearly expressed the importance of grout, the material, and the application form. And finally, it is suggested that Bccce should be a post-grouted rock bolt, should be set as a conditional grouting method for rock bolts. And the study has proved that it fulfilled the deal for leading to a better bolt cement rock bolt. Thank you. I cannot hear you. Professor, I cannot hear you.
Thank you very much for your nice presentation and sticking your time limit. I'm sorry for the inconvenience. So still we have 1 minute for one question. Do we have any question from our audiences? So I don't see any raising hand. Thank you very much. Thank you very much. Thank you. So as I was informed recently, our third presenter, Bccce, is not among us. For that reason, I would like to continue with the last presenter, Ms. Margarita Daiko. In her presentation today, she is going to talk about the evaluation of the seismic pounding between two adjacent RC buildings from Albanian practice. So, floor is yours, Margarita. You have 15 minutes.
Thank you so much, Professor. Hello, everyone. First of all, I would like to congratulate you for all your work and all your dedication. And by thanking you in advance, I would like to start with my presentation. Okay, so as Professor said, my topic of research is evaluation of seismic pounding between two adjacent reinforced concrete buildings from Albanian practice. So this topic is performed.
Can you switch to presentation mode, please, in PowerPoint?
Sorry?
Can you switch to presentation mode, F5? You may try.
Yeah.
Okay, now it's okay.
So So in collaboration with Professor Hussein Bilgin, I have completed my study for the evaluation of seismic pounding between reinforced concrete buildings from Albanian practice. And this is the overview of my presentation for today. I will start with the motivation part, giving some information about what pounding is, what are some global observations of pounding and some observation from Albania as well. And then continuing with the objective and scope of my research and my study, then modeling, analysis and result, and at the end, drawing of conclusions and recommendations. So due to the fast and rapid urbanization, city areas have been, let's say, populated with structures, and due to this, the lack of land usage is observed, and as a result, because of the limited land, the prices of and cost of lands are increased. So for this reason, buildings are constructed close to each other, and not providing this way sufficient separation gap in between. But this is a real issue while during the occurrence of earthquake motions, because due to this insufficient separation gap, the buildings may collide with each other. So this is what we call seismic pounding, which is also known as hammering effect between buildings. So pounding has been observed during different earthquakes in global regions, including here Mexico City during the earthquake of Mexico City in 1985, during the earthquake of New Zealand in 2009, in L'Aquila earthquake in Italy in 2009, in Greece earthquake in 1999, etc. While for Albania, pounding has been observed during the most recent earthquake in Durrës region, not only in the city of Durrës, but also in Tirana, in which the intensity of the earthquake was not as large as in Durrës, but still we can see the presence of pounding damages. So here are some photos that show what causes pounding. So besides from the damages that result from in the building from the earthquake, pounding can also cause the multiplication of these damages, which may be structural or non-structural damages. So in the first photo, there is the example of the effects that pounding has on buildings in L'Aquila earthquake. These are the damages between two adjacent structures in during the New Zealand earthquake. And in the third photo, we have the damages between buildings during the Durrës earthquake. So from Albanian practice, so from Albanian earthquakes, also we have other cases, mostly when buildings do not have, as we can see, enough separation gap. So these are pictures taken from apartments in Durrës city, and these are from Tirana, which, as I mentioned, even though it is away from the epicenter of the earthquake, still the effects can be observed. There are different types of pounding cases. There is the case when buildings with same story heights and the same height vibrate and they collide. Usually the collision occurs at the highest level. Another type of pounding may be the collision between two adjacent buildings where one building where they have different height but same story levels, or another is when buildings have different heights and different story levels, or for buildings that are situated in a row when buildings are colliding each other, or whenever we have buildings that are constructed in areas where soils, when we have soft soils and possible settlements can happen. So whenever a building is settled, then it is displaced and it can hit the adjacent building. So for this study, two existing buildings that are located in Korça region are selected. Korça is a city that is located in the southeastern part of Albania, and it is one of the areas that has a high seismic activity. The buildings that are selected are 111-story and 17-story buildings. They are modeled as two-dimensional frames in SAP 2000, and the story heights are considered to be the same for two buildings. So, which means that we are in the second case for founding observation, where buildings have different height, but they will have the same story levels. They are separated with 10 centimeter separation gap, which is provided by using Eurocode. So in reality, these buildings are separated with 10 centimeters. And in order to see whether this separation gap is adequate or not, a parametrical study is conducted. And so the parameters that are selected, the structure parameters that are selected are concrete class, seismic zone factor, and story height. So to check or to see what is the influence of these parameters, so they are alternated and building combinations are modeled. So in total, there are 10 building combinations, and then linear static analysis is run to obtain the story displacement. The displacement that are obtained are the displacement at the height where pounding will occur, which means that at the highest point of the at the highest point of the shortest building. Then, in order to calculate the separation gap, 5 different code approaches are used, including here Albanian seismic code, which is KTP 89, which is still in force. And then all the data that are taken, that are derived for the separation gap are analyzed, and then based on them, conclusions are drawn. So for the modeling part, SAP 2000 is used. These are the buildings which are existent apartment buildings, and they are separated by a 10 centimeter joint in between. And they are modeled in SAP 2000 as frame elements having the same story heights. And we have one 11-story building and one 7-story building. Here is the separation gap. The first building, so the 11-story building has 3 bays, and the 7-story building has 4 bays, and each of them has a span of 5 meters long. The analysis that is performed is the linear static analysis, and structure parameters that are selected are concrete class, seismic zone factor, and story height. Based on the combination of structure parameters, 10 building combinations are modeled in SAP 2000. So for the structure frame, the column dimensions that are selected is a column with 40 by 40 centimeters, which is detailed by using the specifications of Eurocode. And for beam, we have a 35 by 30 centimeter beam dimensions, again, detailed by Eurocode. According to Eurocode, the soil class that is selected is the C class. Steel bars that are used are S500. The slab thickness is considered 15 centimeter. Concrete unit weight is 25 kilonewton per meter square cube. Sorry, and for the column, only for the column, shear reinforcement are including while modeling. And then after modeling the frames, the parameters are assigned. So while modeling, the parameters are assigned. We have 3 parameters: concrete class, seismic zone factor, and story heights. So for the 3 first combinations, the parameter that is checked or is observed is the concrete class. So with the variation of concrete class, the variation of seismic gap is checked, while the other 2 parameters are kept as constant, which means the seismic zone factor is taken as 0.25 and the story heights are 3 meters. While for the second case, we have the variation of seismic zone factor. So the influence of seismic zone factor is studied, while the other 2 parameters are constant, so which means concrete class is taken as 25, while the story heights are 3 meters. And for the last case, story height is the variable, so it is changing, while the other 2 are constant. And then after modeling all the buildings, all the models, 10 models, the linear static analysis is performed in SAP 2000. Then after running the analysis, all the displacement for both buildings are obtained, and then based on the values of the displacement, 5 methods for evaluating separation gaps are followed. So the square root of the sum of squares, the absolute sum method, the Indian standard of 2016, FEMA 356 separation gap, and the Albanian seismic code, which is KTP 89. The Eurocode implements the square root of the sum of squares, and for each method for seismic gap evaluation, the tabulated values are given. So based on the combinations, all the calculated separation gap values are tabulated. So these are for the first 4 methods, and this is for KTP 89, which is actually implemented in Albania. The most critical case is observed to be the case for seismic zone factor, which is the largest, while the other 2 are 25 and 3 meters. While for the highest seismic zone factor, so for the 4th combination, we see that we have the largest separation gap that is needed to prevent pounding between adjacent structures. So this is the case for all the code provisions. And then the absolute values for seismic gap separation are selected, and they are analyzed. They are graphically represented and then analyzed. So it is observed that with the variation of the grade of concrete, so by increasing the grade of concrete, we can see that the seismic gap separation is reduced. So for grade of concrete, which is 20, the separation gap is 11.39, while when we take it as 30, it is reduced by 11.23. So it means by increasing the grade of concrete, the separation gap that is needed will be reduced. While for seismic zone factor, we can see that the seismic zone factor, the largest will be the separation gap that is needed, which is reasonable, because by having a higher seismic zone factor, the displacement of buildings will be higher. And by increasing the story heights, we see that the seismic gap that is needed will be increased as well. So to come up with conclusion, even though there exist different ways to stop buildings from colliding with each other, the easiest way is to provide the minimum separation gap in between. In this study, we made a parametrical research for the influence that different parameters have in the seismic separation gap, including concrete class, seismic zone factor, and story height. And after the analysis using the models in SAP 2000, it has been observed that by increasing the concrete class, the seismic separation gap between the adjacent structures will decrease. So the larger will be the concrete class provided, the less will be the seismic separation gap, which means by providing a smaller separation gap, we will have less land cost. And by increasing the seismic zone factor, the separation gap between will increase. So for this case, we cannot change anything, because the seismic zone factor is the characteristics for the area where the buildings are constructed. And by increasing the story height, the separation gap changes by increasing in value. So it means that for shorter story heights, we will have a smaller separation gap. And by comparing all the provided values for using different seismic gap calculating approaches, we can say that the actual separation gap that is provided by Eurocode is smaller than the one that would be provided by KTP, which means that the implementation of KTP's separation gap would be much more costly for land costs compared with Eurocode. And for recommendations, since all these data were obtained by using linear static analysis, then it means that the accuracy is not as high as it would be anticipated by using nonlinear analysis. So also further investigations should be taken into consideration. Should be taken into consideration asymmetrical structures, because in here we took the structures to have symmetrical plans. So thank you so much for your attention.
Thank you, Ms. Taiko, for your well-organized presentation. I can take one question if our audiences have. Please. So I don't see any raising hand. So before closing the first session, I would like to thank you all for contributing to this first session of 4th International Balkans Conference on Challenges of Civil Engineering. Now we have 1 hour lunch break. At 2:30, we will be here again with the second session, which will be moderated by Professor Miriam Nidine. Thank you. Enjoy your lunch.
Atje.
Përshëndetje.
Këngjes janë full zyrë tani, po ishin disa
Do fillojmë për pak.
pasojat e tërmetit sipër. Pasojat e tërmetit. Tani të nxjerr ti bëj zoom nga kompjuteri, se unë po flas nga celulari sepse tu iku interneti prapë.
Ja të orienton Enea. Enea, të lutem, orientoje se do flasi dhe me kompjuter dhe do përdore dhe kompjuterin edhe telefonin, se ka kompjuterin pa kamera dhe pa zë.
Është një share screen te kjo te po Enea.
Po, përshëndetje, si jeni?
Përshëndetje, si kaluat? Mirë.
Okej. Mund ta provosh në share screen?
Po. Në rregull doli po?
Po, tani jemi okay.
Okej.
Po kemi edhe 5 minuta, më duket apo jo?
Po.
Kamera, jo, thjesht për ta vendosur. Po bëj full screen të?
Po.
Okej. Okej. Ishe do kënë ndjesh për me një lapsus në anglisht?
Se prit mendjen, gjua e jonë është gjuhë profesionale, kështu që kuptohemi.
Okej. Do të folur në anglisht në Shqip?
Në anglisht është më e mira, sepse kemi edhe
Okej. Atëherë lejoj të bëhet ndërhyrje nëse gabojnë ndonjë term.
Patjetër, ose normale. Se jo.
Po ndjes se kam problem me pozicionin këtu. Mos u tremni nga do të tërmeti mbrapa se ka kaluar si pasoja. Ndjes, një sekundë. Do të sajojmë. S'kam dalë akoma? Okej. Ndjes se kam unë një sekundë. Po mirë, po rregullat të, se jam me dy pajisje. Gjojnë besoj? Sa e thonë stërviti o zysh për një sekundë. Okej. Okej.
Hello, everybody. I welcome you all in this second session that will last till 4:30 p.m. So once again, good afternoon and welcome. Hope that you have a nice break during for lunch break, I mean. Now in this session, we have 7 presentations and for each of them, we have more or less 15 minutes and another some minutes that are for question or for some comments that you might have. So let's begin with the very first presentation in this session. Let me introduce Professor Alket Kumaraku. It is coming from the Polytechnical University of Tirana. He will present a paper with the title, The Alternative Stormwater System versus the Traditional Pipe Stormwater System. Please, Mr. Kumaraku, the floor is yours.
Hello, everybody. First of all, I'd like to thank you for the invitation in this conference. These articles aim to focus, let's say, in stormwater systems, because as you know, actually, we generally design the traditional one, which is a pipe stormwater system. But in existing systems, we could also, let's say, solve many problems using the alternative systems, such as sustainable urban drainage system, which are very known in abroad, but in Albania, if used, they are rarely used, but not with this intention to be used as sustainable urban drainage system, but occasionally, time to time, in order place to place, in order to deliver the waters in the underground water table. As you know, the urbanization is a big problem, not only for other activities of the life or food, etc., but also for the stormwater in the city. There are two main problems. One of them is the increase of the stormwater runoff in the surface of the roads, which brings also, let's say, floodings into the roads, or the higher levels into the receiving water, in the waters of the stream or rivers, where these waters can go on. And the next problem is the lowering of the water table in the underground waters. As you know, this is presented in these 2 figures. So we can solve one of the problems, that the runoff to be maintained inside the pipe system, but we cannot solve the next problem, which is shown in the next figures. So to solve also this, we can, during our design for the stormwater system in the cities, to say the truth, I have many years working in these sectors, but there is so less, let's say, tension in this sector. So for this thing, I mentioned the sustainable urban drainage system, and according to Syria, which is an organization who is very involved in this field, there are 4 pillars, which is in which are based this sustainable drainage system in the urban area. The first is to control the quantity of the runoff, as I mentioned before, to manage the quality of the runoff to prevent pollution, which is not the aim of these articles. To create and sustain better places for people, also not the aim of this article, but is one of the pillars of this alternative system. and this is used more in landscaping design. Create and sustain better places for nature also in the landscaping design. So as you see, there are some fields of engineering, architecture, and landscape, as we call urbanism, maybe I'm right, to be involved to solve these problems. I mentioned in the beginning that the urbanization process is a big problem too, because it increases the runoff. It can be solved by the pipe systems, but we need bigger pipes. Every time the city is going to be, the impervious area, of the system is going to grow up. And here are some let's say, graphics to show the increased peak rate of runoff after, post-development is this. This is post-development, but with flow attenuation, which can be done by this sustainable drainage system. And the pre-development, let's say, hydrograph, which brings lower peak than the after development. Of course, we cannot go to this natural one, but at least we can approach this high flows and the conditions of the terrains using attenuation measures, such as this sustainable drainage system. Here are some examples of the alternative, let's say, system. It can be seen, these are swales. In this both here is during the process of attenuation, is a drained one. This can be used under the squares of the city, is a big tank, let's say, not the attenuation one. It's also another type of, let's say, not attenuation tank, but a system with plastics, which can accelerate the water flow toward the ground. This is an area which can be used for attenuation, but also for games during the dry period. It's a combination, let's say. This is a parking lot with porous asphalt. It is given an example more on the right, how it is function. And to have a clear let's say, panorama of what happens during the attenuation measures, we have made, let's say, a hydraulic model comparing these two situations: a developed area with the traditional pipe system, and the developed area also the same area, but not increasing the diameters of the pipes, but putting some sustainable drainage system. This is an area of part of a city near Tirana, Elbasan. It is there are some maps. Let's say the first one shows the catchment areas more clearly. The second one is the city in the year 1990, and as you saw, and the last is in the year 2015. The impervious area during this, let's say, 25 years, now we are at almost 30 years, has been grown up too much, and as you've seen, is almost in all this, let's say, two catchments. As you've seen, the catchment in the red line has had the half of the impervious area, and half of them is half is impervious area and half has been pervious one. While now in this in the year 2015, is most of this area of this catchment is an impervious area. Not saying 100%, but at least we have evaluated it later. We are going to see later, nearly to 70%. This increase of the impervious area has brought, has brought to increased runoff in the city, and it could lead to some problems. Here are some of the data used for this hydraulic model. The intensities of the rainfall provided by the Meteorological Institute of Albania. These are the data used till the year 1990, still usable today. Then there are the catchment areas data for this hydraulic model. We have separated these areas into apartment areas, which are almost totally impervious area, multi-family attached area, which are houses which are attached to each other. Let's say they are separated by only one wall, let's say, which has impervious, let's say, coefficient less than apartment, but more than suburban areas. The suburban areas are the, let's say, multi-family but detached. These are far away, far from each other, or separated by, let's say, by green areas by each other. So the runoff coefficient is lower. And the unimproved area, which is the area which has been left in the natural condition as it has been before. There are the data of these areas for the year 1990 and for the year 2015. Is the table of coefficient proposed by Bisman and Lewis, from which we have deducted this coefficient, and we have used this formula for the coefficient in this model, and the result is this table above. So as you see, the runoff coefficient in the year for the catchment 1 in the year 1990 has been 0.552, and the year 2015 is 0.58. While in the second area, second catchment is 0.5 to 0.6. In the year 2015, it has been underestimated to take into the consideration other measures we have not measured. We have not analyzed, just to take only this data. Here is the model. As you see, sorry for putting this not in the right order. In the left, you can see the scenarios used for this model. There are scenarios for the year 1990, 10 years, 20 years, 50 years, and 100 years intensities. But we have presented here the scenarios of 20 years for both, let's say, scenario 20 years in 1990 and 20 years in 2015. The situation, sorry, here I presented for the year 2015 two other scenarios or under scenarios. Let's say the first one in this figure and in this figure is without attenuation, and in these figures and here with attenuation. More or less the same difference is even in the next scenarios. I've had no possibility to present all of them. Here are the results. Let's say a storm with a return period of frequency of 20 years has been taken into consideration to analyze the hydraulic model simulation. As we see, without attenuation, we have higher levels of the water and higher energy grade line. This is the water level. That means there is flooding in this area and flooding in this area, even less depth, but there is flooding also, while the energy is higher. It is seen even in the tables under these figures. As you see, in the last columns, there is the confirmation of the flooding. And with attenuation, we see that there is only a small flooding in the third manhole area. And is a flooding with 30 centimeters. I have not presented the area. It was needed another data. While Without attenuation, you see that there are floodings with, let's say, even more than 1 meters and 30 centimeters. So it's higher without attenuation, and it's lower with attenuation, and only in one point, having this result. Sorry. Yes, so here I put the comparison between only this and mentioning only the height of the depth, sorry. Just a short presentation for comparing these two situations without and with attenuation. We see that there is less flooding with attenuation and almost 30 centimeters and the smaller surface. Then without attenuation, this higher, let's say, depth with bigger surface impacted by this flooding. So let's hope that this thing to be used even in Albania, because this system, as I mentioned before, as you see, has lower cost to interfere in the cities and has too much impact in attenuating these floods, these peak flow waters. Thank you. This all.
Thank you, Mr. Kumaraku, for this very nice presentation, because it is an actual issue for our cities, so that we have less and less green area, that we have more and more paved area. So this is flooding, urban flooding. It's a very actual issue indeed. So thank you. But I will invite the audience if you have any comments or any question for Mr. Kumaraku, please. The floor is yours.
Okay. Meanwhile, may I mention something? Okay. This is not only for the flooding, because flooding in our areas could be managed in some ways, or the worst thing, we can wait some hours, which is not acceptable also. But the biggest problem that is it can be seen now is the underground waters levels are going to be diminished or to be depleted, which brings to the problems of drying these waters, and the cities, or let's say the rural area under these levels could not have the forecasting flow by the geology, because it, as I say, the underground water cannot be supplied by the rain in the area we need, but it can be supplied later, which we don't need. Let's say it can go faster even to the sea without how can I say, without
percolating in the groundwater.
Yes, without percolating in the right place where it is needed. That's the biggest problem, I say. Then the first one, then the next one. Sorry.
Adi, any comments?
I may have a question.
Okay, please, Mr. Artan Husa has a question for you, Alket.
Yes, thank you. First of all, thank you for your presentation, Professor. Thank you. For me personally, quite motivating, because I will have a short communication after a couple of minutes related with the topic that you explained.
Thank you, President.
And my question would be just to learn more on this sustainable urban drainage system. How do they deal with the private land? So is there such a, I don't know, such an intention within the model to deal with property rights of the lands that you have to allocate for such solution?
It can be solved during the landscape design with the urbanist. Mm-hmm. But if I have understand well, you say, what about the waters from private properties?
Yeah, in terms of lands that contribute to this solution, which is an alternative one to the engineered network that we have in our city?
From the private property, I think it could be a legal issue, but in Albania, as you know, even for clear things, we have many problems to solve, even if are clear things. But as I know, there are no legal issues to put this in order. So if a private owner or investor could deliver the water with pipe system, actually we cannot stop him. Up to this moment, it's only question of legal, first of all, and the second, it can be held by the landscape design. For this thing, I say that I could do a proper system, a very good system, not by myself or engineers only, but also collaborating with landscaping designer. It should be a strong collaboration with them, and this could mitigate some, let's say, this problem that you mentioned, because inside the private properties, I think it's difficult. If they don't understand, if they don't do, I don't. Only in the public properties, I can say.
Yeah. Thank you very much.
Sorry, this is.
The answer for you, Artemisa?
Yeah, for sure.
Yes, for sure, because in this project you have to work as a team, not only with the individuals, but team on team composed by different fields of expertise. For example, you are one of these experts in the urbanization. I'm talking for Mr. Husa. And even some legal expertise it's needed in such project. Okay, thank you. Thank you.
Answering also some item in Italy, or I don't know, in another country, I don't remember quite well. There is a legal issue which solve these problems that Artan mentioned, but they are focused more over in the sewage system. That's the problem that I say in Albanian most, but even in our country, they are not so much focused in this problem. They are ahead of us. They are focusing more and more. But this thing that Artan mentioned has been solved only for the sewage system. So they have put some barriers by the legal, let's say, by the law, which put the private owners to some limitations in discharging water to the public system. So they take other measures. For example, they use water from the shower to be used even for the water closet, or if with minor treatment to be used for gardening, and not to discharge directly to the public system. It has been so, but not for the stormwater. So.
Okay. Thank you. Thank you.
Yes, thank you.
I think that the answer was clear. Okay. If anybody else has some issue, let's comment after all the presentation, because we have to move on. And now I am pleased to give the floor to Mrs. Mirjeta Bloshmi, who has a paper on some modeling with HECRAS software. And this is for FARCA system. It is a case study. So Mirjeta Bloshmi, please, the floor is yours. Wish you success.
Thank you very much, Professor. Hello, everyone. Thank you for having me on this conference. Let me share my screen with you. I hope you can see my presentation.
It's okay. Okay, go ahead.
As Professor Miriam said, the study that we have conducted is about inundation modeling using HECRAS software, and the case study that we have selected is about FARCA stream. My presentation will start with a brief motivation of this research or study, and then we'll continue with the objectives of the study, a description of the area under study, a description of the modeling. Then the result and analysis will be stated together with the conclusions. Albania, it is defined by national and international researchers to be as a high-risk region related to flooding. This is due to its climatic characteristics, water stream intensity, where the total area of water basins of rivers located inside the territory of Albania is 43,305 kilometers square. And also another factor that names Albania as a high-risk region is its topography features. As it can be seen in the map here, in a period of 1851 and 2012, there was designed a map for the flow geographical distribution in Albania. It can be seen that Shkodra and Lezhë region was the most affected regions one, with a number of 100 to 1,000 flooding events during this period. In Shkodra, it can be mentioned the flood occurred in 2012 and 2011, where 14,000 hectares of land were inundated, 1,200 buildings were flooded, and 12,000 people were evacuated. Flooding tends to produce a lot of economical catastrophes, environmental destructions, etc., concentrating into the economical losses into based on a study in between 1993 and 2013 period. The economical losses due to flooding were about 72% compared to all other natural hazards. So flooding remains a high issue or a devastating issue in not only in Albania, but also all over the world. That's why it is very important to pay attention to flooding. But there is a confusion relating to which model we should use to model flooding, or which type of software we should use. And for this reason, this study is focused on developing two different hydraulic flood modeling, one-dimensional and two-dimensional models. And there is used a combination of HECRAS 5.0.7 software and ArcGIS. On this study, there is performed unsteady flow analysis for both models, and then the results obtained from this analysis were compared in terms of water flow distribution along stream. But to start developing these two models, it is very important to understand the difference or the potentials and limitations between one-dimensional and two-dimensional models. For initiating with one-dimensional models using HECRAS software, it is important to underline that one-dimensional model is a cross-section based model, while two-dimensional model, it is a area-based model or bathymetry-based model. If in one-dimensional model we need to draw by ourselves each cross-section and then interpolate them, in two-dimensional model we just modify the 3D terrain and then we draw the two-dimensional area or bathymetry area. For this reason, for one-dimensional model, it is required detailed topographical data only for the cross-sections, while for two-dimensional model, the topographical data require detail for the whole area. One-dimensional model, on the other hand, requires less time or short time on simulation, so we can perform larger projects or larger models within a short time of simulation, while two-dimensional model have a long time simulation even for a short project or model. If our aim is to model bridges, culverts, gates, etc., we need to use a one-dimensional model within HECRAS. Because if we model these hydraulic structures with two-dimensional model, then the results that we will obtain should not be real. We have selected for the purpose for this study the Parka stream because it has a strategic location. It is located, as it can be seen from the Google satellite, near luxury residential villas known as rolling hills. Also, it is located near the Central Archive of Social Security and the State Reserve depots. In this stream, there are made several rehabilitation throughout the years with the aim to prevent flooding of the area. But on 13 November of 2014, a critical discharge occurred with an amount approximately 240 meter cube per second, and the rehabilitation structures that were constructed there were destroyed, and this caused the whole area to be inundated. Also, many economical and environmental damages occurred. For the sake of this study, the Farka stream were divided in three main segments. The first segment corresponds to the existing stream. There was constructed a trapezoidal concrete channel, but this trapezoidal concrete channel was destroyed during the critical discharge. On the second segment, which is named as the channel, it passes around the Central Archive of Social Security, while the third segment passes near the State Reserve depots, and there it is constructed a culvert with dimensions of 5 by 3 meter. This culvert is not affected by the critical discharge of November 2014. Under the same rehabilitation condition and under the same boundary condition, two models, one-dimensional, two-dimensional, were set up. The rehabilitation conditions were, for the first segment, the trapezoidal concrete cross-section, which was damaged, was destroyed, and it was replaced with a rectangular cross-section with dimensions 8 by 3 meters. This rectangular cross-section tends to pass also along the second segment, while the third segment remains untouched, so the culvert remains untouched with dimensions 5 to 3 meters. For the boundary conditions, two models requires two boundary conditions, upstream and downstream boundary conditions. As upstream boundary conditions, the flow hydrograph was used, where the maximum discharge was 240 meter cube per second, and the downstream boundary conditions, the normal depth was used, and it was calculated to be 0.025 meters. For the one-dimensional model, after drawing the cross-section and interpolating them, it was very important to also input the data of junctions. Two junctions were located in this stream, and the data was carefully inputted under the unsteady flow computation mode, force equal water surface elevation. For the two-dimensional model, the terrain was modified according to the rehabilitation condition, and then the two-dimensional area was constructed, or two-dimensional bathymetry was constructed. After performing the unsteady flow analysis, the water depth planimetry was generated as a result, together with the stage and flow hydrograph for each section or for each segment. Based on the water depth planimetry, it can be said that the water does not overcome the banks of the stream after the rehabilitation, and the area is no longer inundated. Considering the stage and flow hydrograph for the first section and for the second section, it can be said that the maximum discharge for the first section is 240 meter cube per second, corresponding to the maximum discharge of the whole simulation. While for the second segment, the maximum discharge, in this case, it was calculated to be 90.91 meter cube per second. Considering the third segment or section, the maximum discharge was calculated to be 149.09 meter cube per second. Here it is presented a 3D representation of the channel and the mainstream of Farka stream in order to see the distribution of water along the stream. And it can be seen that the water does not overcome the banks of the stream, in both cases, in the channel and in the mainstream of the Farka stream. Considering the two-dimensional model, taking into consideration water depth planimetry for this model, it can be said that also the water in this case does not overcome the banks of the river and the banks of the stream, and the flow is regular in this case. Considering the flow hydrograph, the flow along the first section is the same as for one-dimensional model, where the maximum discharge is 240 meter cube per second. For the second segment, the maximum discharge differs in this case, and it was generated to be 112.3 meter cube per second. And for the third segment, the maximum discharge that this segment can provide in two-dimensional model was 127.7 meter cube per second. After comparing the results of one-dimensional and two-dimensional model, it can be said that this result does not align with each other. This means that there is a difference in between maximum discharge in different sections. For example, in section 1 or segment 1, the same discharges for both models. In section 2, the discharge difference with an amount of 21.39 meter cube per second. This also happened in the third segment. So the maximum difference for two models in maximum discharge was 21.39 meter cube per second. To conclude, models does not align with each other, and to select the most appropriate model, or the selection of the most appropriate model depends on the aim of the project, on the engineering judgment, and also on the time that the engineers and the project have to be developed on this, Thank you very much for attention. I wish it was a helpful presentation.
Thank you, Mirieta. It was a very nice presentation. I really congratulate you. If somebody from the audience has any question or comment, please, you're welcome. Okay. If not, we can move on. And now it is time to see some another paper that it is coming from Mr. Dashamir Gega. Its paper is about the impact of neotectonic processes on existing and future civil engineering works. This paper is focused on Shkumbini Valley, exactly in Dzibrac-Libraj area. Please, Mr. Gega, the floor is yours.
Thank you very much. The rock time contacts on the both sides of Shkumbini River Valley indicate that neotectonic movement from east to east are not uniform. This has been verified through continuous field investigation in both sides of Shkumbini Valley Dzibrac-Libraj area. This research shows the results of this field investigation followed by geotechnical assessment on the impact of this neotectonic process on engineering works. Based on this verified neotectonic movement, as well as the result of this study, recommendation will be given that should be taken into account maintenance of existing works as well as the construction of future works with interest, roads, tunnels, residential center, etc. Here is the point field in Dzibrac-Libraj area, Dzibrac-Mirac area, from geoportal ESIG in Albania, Gov in Albania. Here, we are here in Shkumbini River, in the two both sides, on the north, on the south. Introduction. Field surveys on both sides of Shkumbini River, Dzibrac-Libraj area, point fields, and in slide before, in the framework of previous research on complex relation between one moment, please. this tectonic movement, their amplitude. Okay, thank you. Between of the Scheveningen of Elite Massif and the eastern part of the Veldic Massif of Kutermani-Spat identified. 1. Tectonic zone of shale type X16 in the Valley Shumbin, southeast Labenot-Librash to northeast Morash-Librash area. 2. Movement in general of the massif of Elite Spat-Kuterman from west to east, form morphology from the Shumbini Valley and geological from the Shumbini serve Mokr 3. The intensity of this neotectonic movement, east, west, east, was not uniform, as along from Chesme-Miftarid, parallel to the highway that leads to the village of Babia. 4. The main amplitude of neotectonic movements from west to east in the area Zibrak-Librash is different on the both sides of the river Shumbin. Given that this area passed the railway line Elbasan-Librash with several tunnels that exist in national route Elbasan-Librash and what is planned to be built, the more subject. Neotectonic movement, their amplitude is important in the maintenance and facility of construction of works in the most stable areas. During fields observation, it was not noticed that these two masses move towards is of the Spat-Kutermani towards the east and that of Shumbini towards the east. This movement in the brush intermountain pit was created with molasses deposit in the brush city, and the brush city was built on this deposit created by this neotectonic movement as inhibited center from the brush to Bccce. During the field study of the Shumbini River, it was noticed that this represents a zone which emerges in the village of Babia and continues a shale zone which emerges in the village of Babia and continues towards the southwest with alluvial deposit of Shumbini River. Here on geological map of Albania, here is the zone of study Zibrak in the west and Librash in the east. Here on the right, there are two massive Spat-Kutermani in the west and massive Scheveningen on the east. The powerful tectonic zone at a length of 10 km clearly shows that the movement of the rock blocks on the both sides of it in time and space was not uniform. The north arms is moving 300 to 400 more advanced towards the east compared to the west. Given that in the length of 10 km, according to the Shumbini River, is built the national route, railway line and construction of Corridor 8, Doğru, Skopje, Sofia, Istanbul, is necessary that the construction carried out in the northern part of the river Shumbin to be reviewed in the framework of this phenomenon to be improved, a new construction to be concentrated on the western side of the river Shumbin in this area of 10 km long Zibrak-Librash. The tectonic and neotectonic phenomenon was studied by petrographic rock in the section Zibrak-Librash. In Zibrak and at the very end of the national route Elbasan-Librash, we have the petrographic contact between the carbonate deposits and the Cretaceous and the crushed fish of the Middle Eocene, with coordinate north on 41, 09 and 23, east 20 grade 11 and 40 second.
Sorry to interrupt you, Mr. Giga, but you have to move on because we are in time.
What, please?
We have to
Okay,
finish.
thank you very much.
Continue. Okay.
This petrographic contact in the southern part of the Schombin River with coordinate is shift towards the west with horizontal amplitude 350 meter. Continues eastwards in the village of Miraca. The petrographic contact between the massive limestones up of the Upper Triassic and the thick flysch melange is found on the other side of the Schombin River. This petrographic contact in the eastern part emerges on the right side on the highway and the point with coordinate on 41 10 minute 10 second east 20 grade 15 minute 0.05 second, while in the southern part is emerges on the point with coordinate with a displacement of 350 meters. Evidence of the tectonic zone in the village of Babia, and it is pursued towards the southwestern for 10 kilometers along the Schombini River, shows that the Schombini River in its studied lengthy brushed crusted basin represents a tectonic zone with two wings in north and in south. Here is in the west, here in the east, Schebenit Massif, and the direction of movement from east to west. This picture is another picture that the direction of the movement from east to west. It is Spati Massif. Methodology: both blocks move eastwards towards the city of Libres, where in its vicinity and of the vicinity they an angle up to 16 shown in the next slides. But what is special and distinct in that the northern side of the Schombini River moves faster than the western one. From today's measurement, according to the petrographic contact on the both sides of it, we have a movement difference of 320 to 350 meters. The west side is less stable as it moves less. A part of the railway tunnels of the Bassin Librage line have been built on this side. A part of national route at Bassin Librage passes on the northern side of the Schombini River and has had engineering problems at certain times. Evidence of non-uniform movements of the rocky wings north and south of the Schombini River requires that in the future, in the construction to be carried out by taking into account the tectonic laws, which occurred at different geological time and no technique that continue and day after day giving the appropriate recommendation in the protection of works built and those to be built. Here is the contact, the petrographic contact between Blackstone and Flysch in north of the river of the Schombini River. Conclusion. The study of two of the largest massif, Schebenit in the east, of Schombini Valley and Spatkulermon in the west, identified the movement of the Schebenit Massif along its entire length from east to west, and that of Spatkulermon from the west to the east, creating the mountain pits where then formed the molasses that we meet today from the south Bccce to Vanares in the north. But then continuation of this movement created the Shkumbini syncline with its two wings, the western on that meets the east and the western meeting in the west. According to the Bassin-Librage axis, a tectonic zone developed according to which the Shkumbini River flows today. This tectonic zone met in Babia and converged to the southeast by alluvial deposit has a considerable length over 10 kilometers. Movement to the east on both sides of this tectonic zone that runs along the course of the Shkumbini River are not uniform in the time and space. The north wing moves faster in the time than the south. During the observation, the same petrographic benchmarks were fixed on the both sides of the river. Future monitoring of the amplitude of movement of this petrographic to take to be the data of the intensity of the movement time. Making measurement every 10 years in the reference point reflected above, we would design accurate projects on the works that are expected to be built in this area. On this basis, the construction of major infrastructure works in the future on the existing Bassin-Librage should be built in the southern part of the Shkumbini River. Construction in the north part would require additional engineering measures significantly increasing their cost. The engineering works built in the north part, especially the railway bridges, must be repaired in the time, given that the movements are not homogeneous. Monitoring of horizontal movements in the time unit, most suitable 10 years unit, would provide data and the lifespan of the constructed objects and the engineering measures to be taken. Thank you very much.
Thank you, Mr. Gega, for your research and your conclusions. If somebody from the audience has any question or comment for these topics. Okay, we'll move on. If somebody has something, we can still continue after all the presentation are done. Now I will give the floor to Mr. Alush Shala, that together with Jelena Bleifitzer, if my pronunciation of the surname is correct, they have a paper, they have worked together, and they come with a paper on the effects of errors on execution and design of key details in the object. So, Mr. Shala, please, the floor is yours.
Thank you. I first will share with you paper.
But keep in mind, please, that you have 15 minutes, okay?
Okay. I don't know. I don't know how to share.
Do you need any? Okay. Do you need the support?
It's okay now.
Okay, it's okay. Yes.
Yes.
We can see.
Thank you. My paperwork is effect of errors on execution and design of key details in the objects. My paperwork contains introduction, buildings, and image description, discussion on the causes of the damages, rehabilitation of the building, and conclusion. Introduction. During the visits in Albania, in the assessment of the damage of the objects, some errors during the execution of the details were encountered. Working out the details of the structural elements correctly has a great value for the building. During the inspection, destruction not only of old buildings but also of new ones was encountered. Therefore, the details of the joints between the columns and the beams, reinforced concrete walls and slabs, foundations, placement of seismic walls have a major role in the building, and great care must be taken in execution. Care should be taken especially in seismic areas starting from the first stage of design, preparation of the main of execution project documents, to the phase of the construction and supervision works. However, the biggest damage may be attributed to age, errors in the realization of details, lack of strict supervision, and in certain cases, even the design drafted that does not conform to standard for areas with high seismicity. In seismic areas, the analysis of local ductility of vertical elements has particular importance. Checking the local ductility of vertical elements and meeting the condition of Eurocode 8 should provide a security for the building in the resistance to additional seismic impacts. This increases the quality of construction, increases the bearing capacity and service life of the building. This paperwork presents the most serious damage that was observed by illustrating them with example and photos from site. Depending on the damage, structural elements, walls, slabs, and foundation, and the possibility of repair them or not. All this evaluation should be according to European technical norms of construction such as Eurocodes and local technical norms. In the paperwork, some ways of rectification of buildings to be safe and sustainable are proposed. Finally, the conclusion of this paperwork summarized the findings and the way for future research and opportunities to address field problems and construction of capital projects. Buildings and damages description. During the visit to Albania after the earthquake that occurred in November 2019, various damage to various buildings was found. The facilities were built from 1930s until recent years. The damage is mainly cracking of the plaster, which is mainly in accordance with the description in the European norms for this type earthquake, as in photo 1, here in photo 3 and 4. Non-compliance with the protective layer, as shown in photo 2, was also found, as well as failure to realize the detail of the reinforcement according to the technical condition minimum dimensions of supporting columns. See photo 6 and photo 8. Improper positioning of seismic walls is accordance with the technical condition in seismic areas or even without seismic walls. In the old buildings, there were cracks in the plaster due to thick layers of plastering, displacement of bricks, and damage to the bonding between them. See photo 3. In the upgraded building, which added new floor or stories, there were many cracks in joints between the old buildings as new floor, as photo 4 here. There were also cases of buildings built in 1990 to 2000, where the beam was supported in wall, photo 5, and not connected to a cross beam over the wall, which resulted in its displacement in transverse direction. There was also from the age damage from the age and the observation of the moisture of the consequence. There were reinforced corrosion, as in photo 7. From the corrosion of the reinforcement, there is a change in diameter of reinforcement river, which, with the action of additional earthquake force, has led to appearance of cracks and other damages. discussion on causes of the damage. During the design, execution, supervision, and maintenance of a building, errors can occur. Errors are different nature, such as from non-compliance with technical norms in the respective areas, errors from investitor pressure, errors in execution due to negligence, errors due to ignorance, errors in the supervision phase, and errors during the maintenance of the building, errors in the design phase. If we look carefully at the stiffness of the building in the design, we notice there is negligence in respecting the regulation. The distribution of stiffness and masses is not appropriate. The solution encountered and shown in figure 1 are unfavorable for seismic areas because they represent a soft flooring or soft story. On other floors, there are brick wall filling space between columns and beams. We proposed a solution how need to design the project or floor as figure 2. Another error accounted in the design phase is presented in photo 5 before. Photo 5. Where there is a beam supported by a wall but is not connected to the beam in the wall of the building. Here is a displacement from the support in transverse direction. In seismic areas, it is advisable to provide strategic beams to have a better connection. We presented in figure 3. This is in site execution, but we propose to make an appropriate detail that to have a beam over the walls and to connect it with a beam, transverse beam. We have errors in the construction and supervision phase. An example of execution errors is the connection between the column and beams. The photo 6 and 8, as shown 6 and 8, present the errors in realization, while the figure 5 here is presented the regular execution as Eurocode 8, when the width from columns need to be bigger than thick from beams. Figure 7 shows the appropriate way to reinforce reinforcement layout for building in seismic areas. This detail satisfies the seismic requirements. On laying reinforcement, especially the detail, see figure 7b. During field inspection of damaged buildings, the omission of reinforcement of beams and columns near to the joint has been noticed, thus not compliant with the recommendation of Eurocode 8 from HOP's maximum distance near the joints as figure 7a. The control of local ductility also plays an important role in the columns, always taking into account the observance of the normalization coefficient of axial forces (Ni-D). Another errors might be attributed to the design, supervision, or execution is shown in figure 9, errors in stair support. The photo 10 shows the creation of short element in the column, which is not appropriate design of the stair support. In seismic areas, one must always eliminate such elements by creation stairwells and walls to support the stairs in the area between floors, as in figure 9. In figure 9, we proposed 3 solutions to support the stairs with stair cores and walls in the side or in the front. We have a solution for adequate supported stairs in the floor in figure 8b. Rehabilitation of we have following we have the following description of defects due to thick layer cluster, which is a problem itself, the action dynamic seismic impact. In photo 1 and 3, one can see cracks with are due to inadequate treatment of the plastering layer, exceeding the optimal layer depth without the use of additional reinforcement, such as reinforcement mesh, FRP, or similar materials. Rehabilitation. Now have a rehabilitation of building. Before deciding or rehabilitation or renovation for damaged elements, a commitment is first required to identify the damage and address to reasonableness of the rehabilitation or renovation. In every phase of the rehabilitation process, acceptability criteria plays the additional role from the initial evaluation to design process and quality assurance of the erection process. The stage must be followed in the process area, strategic document, concept document, or detail document. Each stage contains the activities that must be followed. Very important is to propose of the performance of facilities in rehabilitation. A rehabilitation objective consists of one or more rehabilitation goals. Each goal consists of the selection of a target building's performance level and earthquake hazard level. See figure 10. Throughout a facility evaluation engagement, one needs to do general analysis and facilities modeling according to the requirement. Due to the dynamic nature of seismic action, the structural model should adequately represent not only the distribution of stiffness, but also the distribution of mass within the structure. Special attention should be addressed to joint between structural elements which are not explicitly modeled when their stiffness differs significantly from the fully rigid or pinned assumption, or when their strength is lower than one of the connected elements. Therefore, during the evaluation work, the secondary effects are very important as they have a large impact on the structural stability after the building has experienced an earthquake. Some of the ways of rehabilitation are using concrete injection of crack or ceramic metal mesh, use of different polymers for wall reinforcement. In the case of the most severe damage to the columns, different hydraulic equipment should be used to raise the facility to the previous level and then start with repairs. Otherwise, only if passes the evaluation test by the relevant engineers. Here we presented some figure how to repair walls and how to repair columns and beams. And finally, conclusion, based on the funding from the field and the analysis of defects encountered in the field and the documentation presented, it can be concluded that more strict implementation and complying with technical norms of seismic area would reduce the damage. Before starting renovation or demolition, a proper analysis to determine a realistic assessment of the conditions of buildings is needed. Damage can be attributed to poor maintenance of concrete and some inadequate detailing for structural and non-structural elements. The use of seismic walls could reduce the risk of property damage and personal injuries. A more rigorous control by the state institution when issuing permits and carrying on-site control for the realization of the objectives could also improve the situation. This is for this paper. Thank you for your attention.
Mr. Shala, thank you for your conclusion and recommendation. They are very practical. If somebody from our colleagues has any comment or question, please. Yeah? No? Nobody? For the moment? Okay. Thank you. Thank you, Mr. Luchala, once again. Now let's move on. And now it's the turn of Kimon Hadjibiros. And his paper is focused on sustainability as a civil engineer's responsibility. Please, Mr. Hadjibirios, the floor is yours. Okay, but we cannot hear you. We cannot hear you. Mr. Hadjibirios?
Yes, can you hear me now?
Now, yes. Now you
Okay.
are okay. Thank you.
Thank you very
Please,
much.
introduce yourself and begin with the presentation.
Thank you for the invitation and greetings from Athens. I am emeritus professor at the National Technical University of Athens. And today I will try to change landscape and speak about the theoretical issue, sustainability as a civil engineer's responsibility. Just a moment, please. Okay. So, civil engineer can be considered as opposed to military engineer, and he should promote peaceful and sustainable human development. To reach sustainability, a complicated scientific approach is needed because in order to have a good development, we have to establish rules and constraints. Human activities may very often have significant negative impact on the state of the environment and also on the socioeconomic equilibrium. Civil engineers are the main agents of infrastructure works, but important infrastructure investment cannot be realized with the imprudent way of the past. To balance society's need for solid and functional infrastructure with sustainability, we have to be able to understand the environmental, social, and cultural context of the work of civil engineers. Both technical aspects, but also environmental aspects of the physical and cultural environment should be taken into account. Civil engineers have to develop appropriate management and technological treatment of the negative aspects of what they perform. Especially during our 21st century, the works of civil engineers will face challenges related to big international problems like climate change and energy transition, as well as with social and cultural issues which we meet especially in developing countries. We have to keep in mind that the science of civil engineering is connected with most of the exact sciences, as well as with social sciences. For example, it is certainly connected with hard sciences like physics, chemistry, material sciences. Also with the sciences of life like ecology, biology, forestry, and also geology, and sciences of the hydrosphere and atmosphere, Of course, there is a strong aspect of technological science and also medicine, but also a part of social sciences like economy, history, and law. So we have to look for good management, but good management should be the maximal possible conservation of the environment and at the same time an optimal satisfaction of human needs. A complex problem that transcends the abilities of the simple quantitative mathematical models of optimization. Today's civil engineers need to be more than individuals who simply like mathematics and science. Provide technical and managerial solutions in measurements, modeling, and also in the application of scientific and engineering methods. Civil engineers have to understand complicated economic, social, environmental, or urban systems, which usually have several quantitative and also qualitative approaches. That means that civil engineer should be a creative problem solver who help to shape the future by improving health and safety of people. The tool to reach that objective is interdisciplinarity. Interdisciplinary approach is necessary for green development. Civil engineers should possess a circumstantial knowledge of the problems. Introduction of interdisciplinarity, however, is difficult in the way of thinking of civil engineers. Their training is usually overly oriented towards the application of techniques that arise from concrete models. In order to penetrate a long-established mechanistic mentality of civil engineers, a difficult target, it requires a substantial education on the structure, the function, the particularities and vulnerabilities of complex environmental and social systems. So the introduction of a systemic way of thinking can allow integrated synthesis and account the quantitative or qualitative view of a complex reality. In front of all these problems, one possible answer is to teach humanities to civil engineers. Humanities offer integrated ways of thinking that include uncertainty, doubt, and skepticism. So beyond technical aspects, civil engineers have to know why, how, and where they apply their skills. A substantial part of their education should address the great questions of Western civilization. They should study classic thinkers like Thales, Plato, Aristotle, Thucydides, Lucretius, Shakespeare, Descartes, Hobbes, Locke, Kant, Mill, Marx, Nietzsche, Freud, Popper, Keynes, and many others. In the National Technical University of Athens, we have started since 2 years in 19 a mandatory course on human sciences. Among other, we tried to study Thomas Hobbes' thought and combine it to applications on a specific civil engineering work and also on the actual coronavirus crisis. So this is an example that could be useful for future education of civil engineers. Thank you very much.
Thank you, Mr. Hadjibiros. If any of my colleagues have any comment on this topic, on sustainability and responsibility of a civil engineer, we are aware of this topic. Thank you. Thank you. Let's move on. And now I am pleased to introduce to you Mr. Artan Büsa, and he will come with a presentation in Land for Flood network as an opportunity to bring together diverse stakeholders in fighting flooding beyond engineering solution. It is a part of project as well as I know.
Yes,
Okay.
Thank you very much.
Mr. Büsa, please, the floor is yours.
Thank you very much, Professor Andini, for giving the floor. Let me share the screen. So is it visible as a full screen? No?
Yes, it is okay. Thank you.
So first of all, I want to thank the previous speakers, Professor Kimon and Professor Alket, because they, in a way, introduced, or let's say, set the ground, the theoretical background of this presentation. After that, I want to thank the organizers for accepting this presentation, because at the very end, it's not delivering any original, let's say, output of research, but instead it's more like spreading the word, like a promotion within the dissemination activities of the cost action project Land for Flood. And as it is stated in the title, it's more about a new way of thinking beyond engineered solution while dealing with the urban flooding. So the focus is urban flooding, but for sure, let's say, the scope and the way of defining the problem is much more wider, going to the catchment area. So I'm presenting as a representative, as a committee, management committee member, representing Albania and Epoka University. So the whole, let's say, approach is based on the consequences of climate change that are expected to enhance the frequency and intensity of future flood events, which may lead to higher costs of flood damages and increase public demand for protective measures. This is a chart from a study which delivers in a way the level difference, the fluctuation of frequency and intensity of River Rhine. You can see the 5-year average and the current level of the river. And we can very easily see the difference, the change in the frequency and intensity of the river levels. And the idea is how to deal in urban areas with such cases, where we have the peaks and the emergent cases. Another chart is from another report from MDOT, so International Disaster Center, where they report continuously the flood events worldwide. And here we can see the increasement through years on the number of reported flood events, as well as the reporting countries. So in a way, it's very visible how frequent they are becoming, the flooding. And coming to the question and to the way how we deal, how we respond to this issue in urban areas mostly, normally, as we know, the classical way of solving is based on gray infrastructure, the dikes and dams, but they are not sufficient to deal with the dynamics that are becoming much more severe due to the climate change consequences. And instead of that, here it comes the nature-based solutions as an alternative, as a concept, a new concept. A special, let's say, ways or model is natural water retention measures, which are more promising in dealing with urban flooding, but in a way to be, let's say, thought as a complementary solution rather than a replacement totally of the gray infrastructure, for sure. So we have here a table from another study. It's a report from World Bank Group. Well, they have reported, they have, let's say, structured the combination, how these components of gray and green infrastructure can work together. I'm not going to go in all of them, but we can focus on the urban flood management issue as a service. The gray components are storm drains, pumps, outfalls, while the green alternative or complementary components can be storing the storm water in certain areas within the urban side. So in certain lands, they're appropriate for storing water. We had another, let's say, recent study, which, so this is a graphical abstract of this study. Let me refer to the image. Sorry. So as you can see, it's a model that have 6 steps in overall. The first one is the main one, which delivers or defines the study area, which for sure the focus is on the urban area where we have the highest risk, but defining the study area within the catchment, the larger catchment area, including the upstream basin, is very important. After that, this is the new approach in the second stage, where they have implemented a kind of measuring the elements in the landscape that can hold this rainwater and can minimize, in a way, the impact in the low stream areas. A very interesting example from the practice comes from China, where they have started an initiative in 2015, the concept of sponge cities. At the very end, they have thought that cities by themselves can be organized and planned to function like a sponge. So certain areas within the city can absorb water during extreme rain events. And at the moment, they have been successful in doing that. And by this year, normally, they had to reach the 80% of Chinese urban areas to absorb and reuse their 70% rainwater. There are certain elements that are contributing on this objective for sure, which are mainly green elements. Especially this image is very, very interesting because it is exemplifying by real case what types of land uses and what types of functions can be used for temporary flooding retention, let's say, usage. But in other times, they can be used for recreational areas with no problem at all and function as a normal urban space. So coming to this new way, for sure, this new way, it's adding and it's providing at the same time ecosystem services, not only a solution for the flooding issue, but as well contributions to the biodiversity and recreation within the urban functions. So coming to land for flood, this is part of the aims and the problem definition within the project. Since all natural water retention measurements primarily need to be implemented on private land, the consideration of multiple aspects are included. In fact, this is related with the presentation of Professor Alked. So the question that I asked, in this project, that is the key point, the key conflict that generally is being faced in this kind of approach, because most of the land that you have to appropriate for this kind of water retention measures can be private lands. So it's a property conflict in between. And that's why this approach have some issues related with economic, related with the property rights, related with public participation, because you have to include the people of the place to make it happen at the very end. And you have to think of alternative schemes to subside the new interventions. This is a screenshot from the cost action. So the chair is Lenka Slavikova and the co-chair is Thomas Hartmann. So the Land for Flood cost action aims to address these different aspects and to establish a common knowledge base and channels of communication. This is very important. So channels of communication among stakeholders, among scientists, among landowners in the place. So this is related a little bit with the presentation by Professor Kimon, where engineer must be part, so a part of this network. So if I have time to go through key questions of the project, so which synergies can be identified between different land uses and the provision of flood storage and ecosystem services? How can the knowledge base about advance and potentials of natural water retention measurements, large-scale flood retention and resilient cities be strengthened, and their importance communicated to different actors at the local, regional, and catchment levels? A third question is, how can landowners be encouraged to adopt land uses and land management strategies which allow for increased water retention capacity? And the fourth one, how can public and private stakeholders in urban and rural areas engage with each other to reduce flood damage through a comprehensive management plan based on the implementation of retention and resilience measurements throughout the catchment? So within the project, Land for Flood project, we have three main working groups. The first one is dealing with environmental conditions. Mostly here we have the professionals in the fields in different disciplines, where they have to work on the effects of land on catchment hydrology. The second group is social political context. So as we discussed in the first presentation of our session, there are other issues behind. So they relate with social political context of the place where you are having the project. And the third one is mostly dealing with communication. So building those bridges of communication among stakeholders, because without that communication, it cannot happen. So that's why all, let's say, professionals were aware that we must do differently. But if we do not communicate well with all actors, it may not happen. In fact, I have included some other details which I don't want to go in detail now, because maybe those that are more interested can find this information very easily in the website, but there are different detailing on the tasks of each group. But if I have more time, I don't know, Professor Miriam, I would like to share a 5 minutes or 4 minutes.
Yes,
video.
you can.
Yes.
You can.
Because it is briefly explaining what's Land for Flood about, explained by the key persons in the project. So is the audio coming to your side? Okay, thank you.
Yes, it's okay.
Sorry.
Why do land and flood risk management come together? Well, in order to manage flooding, we're going to need to store a lot of water, and that water is going to need to store somewhere. So we need to store it within catchments in cities on private land. So there's a need to understand where to store it, how to store it, and how to compensate people to store this water. I think we have.
Can you turn on a little bit louder the audio, please?
Sorry.
Hard defenses, but now we realize.
Sorry, Professor Miriam.
A little bit louder, the audio.
Let me see. So this is almost the maximum now.
And still the problem is there and it's growing. So we have more damage than in the past. And I think we now need to consider how to involve land as a means of generating floods, but also a means of being affected due to flooding.
Humans occupy land and they change, they engineer the land to conform to producing certain outputs that we desire, whether it's agriculture or city development. And that change in the landscape affects the way water moves, how it's retained, and its speed, which influences flooding.
Well, so much of the land which is actually affected by flood possibilities is often in private ownership. So consequently, the issue of looking at using private land to hold back water which might be generated by sometimes climate-driven flooding is so incredibly important to look at that particular issue.
I think the really important thing about land for flood and about realising flood risk management measures is recognising those rights that people have. So property owners, tenanted land is really important in order to be able to realise some flood risk management measures that we recognise not only the hydrological elements and not only the cultural and social elements, but we bring those together.
It's very important and very interesting because the main challenge of cost action is really to get people from all European states and to bring them to one place several times and really to create new research agenda.
I think the cost action is a fantastic opportunity to bring together different disciplines. It's a way in which we can meet regularly in order to start off lots of different initiatives.
It's very nice to have lawyers and planners and hydrologists, sociologists and economics on one place.
It allows me to meet new people, new researchers, discuss new ideas, or even today finding out about new modelling tools that can take and advance the subject area. So at the moment when we think we're doing things correctly, are we really? We can learn a lot from our neighbours.
But something that's quite critical to innovation generally is bringing disciplines together and working across the boundaries of disciplines in order to really accomplish the innovation that we see to be advanced in practice.
Since I am a member of other cost actions, I have really stressed out that this one has some special positive energy. That was my impression from the first meeting.
I'm impressed how people are dedicated to solve this problem of the world, to go beyond in reducing the risk of flooding, and the respectfulness, how people communicate with each other.
I think personally, I knew some people in the group already, but I met so many more people, particularly people from different disciplines. So for me personally, it's been a kind of opening my eyes to the different work that's going on. And
what amazes me most about the group Land for Flood is the diversity of people here and just conversations you can have, even over things like breakfast, about different compensatory mechanisms for storing floodwater that you didn't even think about. So it's that diversity of people here and the multidisciplinary, transdisciplinary approach.
How large and expansive the network is, to have more than 30 countries involved in a common activity of this nature is very impressive to me.
Mainly scientific institutions are taking part, and I would like to encourage more NGOs really to become active in this kind of network schemes and to see them as a potential for gaining new knowledge, new ideas, and also launching new initiatives.
It's a good start if you want to get somewhere.
Okay, so this was, let's say, a video explaining what's the project about briefly. In fact, so I can say that it's a network of networks because it includes many other organizations that are part now of the project. And if you are interested in, you can check more in detail the main website, or you can contact, so for each country, the respective representatives. So this is a last announcement for the early career investigators. So the early career researchers. It's an announcement for short-term scientific missions for which we can apply, and you can find other details in the website. Thank you very much.
Thank you, Mr. Lisa, and wish you success for further success in this involved in this project. Now, if somebody has some question for Mr. Lisa, want to ask something about this project? Okay. So we will move on the last presentation, but I have to say the last but not the least, because it is a very good research work done by Mr. Mehmetai, Izzet Mehmetai, and he will come to present us some computational fluid dynamics modeling for the submerged vegetation in the open channel. So Mr. Mehmetai, please, the floor is yours, and wish you success. Izzet, are you there? Okay.
Yes. Hello to
Okay.
everyone. Good afternoon. Hope you are all doing well. In this presentation, I'm going to tell you about research work that I conducted together with Professor Miriam regarding the CFD modeling of submerged vegetation in open channels. I want to start by expressing the motivation for this research. The study of the presence of vegetation is not new, but very important when it comes to managing the water courses in open channels, for example, in the case of floods. In Albania, floods occur very often, and the need to find solutions sometimes costs a lot and has an impact on the environment, so finding a sustainable solution in this case is more favorable. The vegetation in this case can raise or decrease the risk of flooding, taking into account the additional flow resistance. On the other hand, it is known that the flow resistance is a parameter that can be used to control the flow levels in the open channels. The engineering approach in this case requires more understanding of the hydraulic properties on water streams with vegetation, much less in Albania. So it is necessary to have a tool that could allow the quantification of this effect for better management of the open channels. And before this is done, we need to understand what the importance of vegetation presence is concerned with, like greater roughness on the channel bed, slowing down the flow, greater resistance or impact on channel geometry, capacity to overcome the floods. In order that this issue to be predictable, is required a better understanding of hydraulics of flows with submerged vegetation to provide an assessment of the impact that the vegetation has on the management and the ecology of water streams in general. Therefore, in this research, this work, let's say, objectives have been set. So the first one, it is to study the hydraulic characteristics of channels with submerged vegetation, to investigate how the characteristics of submerged vegetation related to the distribution of the vegetation geometry influence the flow of water on open channels. And the last one, it is to create a CFD approach to identify the parameters that contribute to the additional resistance as the result of the presence of vegetation. To achieve these goals, it was necessary to gather information as a recap of all the most important information about this subject that are mainly related to these aspects: fluid mechanics, dynamics, so some theoretical aspects regarding the open channels, vegetation impact on the open channels, velocity, turbulence, or flow resistance, numerical modeling. Here are discussed published researches on vegetation in open channels. Generally, they are studies which are based on the CFD, but most of them are one-dimensional or two-dimensional models. The most famous one is Wilson's approach, which is known also as the drag approach model, where the vegetation appears as a rigid cylinder array to simplify the vegetation form in water streams. The classification of the vegetation in open channels and the main cause of vegetation presence. And the last one, it is related with the formulas for determining the roughness in channel, so related to resistance measurement in open channels through the Manning coefficient. The methodology followed in this research is the computational modeling implemented through the ANSYS CFX This software has been for over 20 years for CFD, and through it, I have made a 3D simulation where the mathematical equations that are actually describing the flow into open channels are solved. In the case of flow turbulence, the RANS model is applied, such as the standard key epsilon turbulence model. The main steps of this methodology, which will be explained also in the ongoing slides, include the geometry, meshing, the physics definition, solver, and the last one, the post-processing. In detail, these steps have to do with geometry. The model is constructed geometrically with the help of a CAD tool. The mesh discretization occurs as a numerical method to solve the RANS mathematical equations. Physics definition, the boundary conditions are defined in order to assign the fluid properties to the solver. Computation occurs until the equations are converged. And the last one, it is related with the post-processing, where the visualization of the results obtained is possible and useful. Now, coming back to my research, by following this CFD approach, I did like this for each of the CFD steps. Regarding the first step, which is the geometry, the fluid domain that represents an open channel is rectangular and has the dimensions as it is shown in the figure on the right. 3 cases are taken for study, and each of them is modeled separately and represent a different configuration of the vegetation. 3D view of each case suggests that 3 types of distribution in the space of their cylinders or length that represent submerged vegetation. Specifically, in the case 1, we have a parallel pattern. In case number 2, we have a stagnant pattern. And for case number 3, we have a parallel pattern, but in 2 different lengths. The vegetation for case number 1 and number 2 has a length of 120 millimeters, while for the third case, the lengths are 120 millimeters and 160 millimeters. The arrow determines the direction of the flow. Meshing is automatically generated by the CFX to represent the geometry and the surrounding fluid domain. The discretization in this case follows a finite volume method technique. Meshing, in fact, serves as the input for the numerical solution of the equation which are describing the flow. Regarding the modeling of the flow and its characteristics, some boundary conditions are assigned. In total, there are 5 boundary conditions that are set. Inlet, the boundary from which the fluid enters with a velocity distribution, as it is shown in the graph on the right, which resembles the velocity distribution of an open channel in real conditions. The outlet, the boundary where the flow goes out. Walls for the open channel side faces and the vegetation. The flow cannot pass through the side walls of the channel, and the geometry itself represents the vegetation. For these boundaries, the no-slip condition is set so that the flow at these boundaries has a relative velocity equal to 0. In other words, the flow sticks at these boundaries. The symmetry, to describe the open channel free surface, the symmetry boundary conditions is applied. Such a boundary enables both the pressure and the shear stress to be 0, as it is in a real situation. And to measure the influence of the vegetation, a time-dependent simulation is made, or transient as it is called. The simulation time is 25 seconds, and it is determined that the iteration process for solving the equation to take place every 2 seconds. To describe the turbulence, a RANS type, as I also mentioned it before, of K epsilon turbulence model is taken. This is the simplest model to describe the turbulence, as it requires only the boundary conditions to be set. Regarding the solver enables the reading of all the mesh by solving iteratively all the algebraic equations. Iteration is made up to 100 loops and ends with the convergence. And at this phase, this is the end of the simulation. The last step of the CFD is post-processing. In the case of the ANSYS CFX, it is accomplished through the CFD post. CFD post enables a visualization of the results like the velocity variations or turbulence kinetic energy fluctuations. Additionally, these are the vertical velocity variations, contours for the case number 2, case number 1, case number 2, and case number 3. Next, these are the TKE contours for the case number 1, case number 2, and case number 3. Regarding the interpretation of the results obtained, it is focused on these considerations: velocity variations at vegetation and non-vegetation zone, turbulence kinetic energy characteristics for the flow irregularity, and the flow resistance evaluation and investigation through the Manning coefficient, to see how it has changed due to the presence of the vegetation or not. To see how the vertical velocity has changed, two locations of interest are assigned. The location number 1, it is assigned in the vegetation area, while the location number 2, it is assigned directly after the vegetation. In this way, data are taken to construct these graphs of the vertical velocity change versus the depth of the flow for both of these locations for each case. The dashed line indicates the length of vegetation for each model case. It is noted that in all 3 cases, the variations in velocity are very noticeable, especially in vegetation zone. The velocity is slowed down, and compared to the initial speed, it is reduced in these quantities. For the case number 1 at 60%, for the case number 2 at 40%, and for the case number 3 at 48%. To see how the submerged vegetation distribution and geometry influence the velocity variations versus the depth of the flow, 2 graphs are constructed, including 3 model cases for both location of interest, vegetation and non-vegetation area. The vegetation density for the cases is different. We have 850 rods per meter square for case 1 and 838 rods per meter square for case 2 and 3. From the graph, it seems that these geometric and distribution characteristics have yielded different results in terms of the changes of the vertical velocity of the flow, especially over the vegetation zone. This influence is noted also close to the non-vegetation area as it is reflected in the second graph on the right. As far as for the characteristics of the turbulence kinetic energy and their variations, they are very visible in the vegetation zone. This type of TKE distribution also reflects the changes in speeds in the submerged vegetation area. For the evaluation of the resistance through the Manning coefficient, these graphs were taken for both locations of interest. In the vegetation and non-vegetation area, it is noticed that with the increasing of the depth of the flow, assuming 0 levels at the channel bed, the Manning coefficient is reduced, so the resistance is smaller. For the vegetation zone, this changes because vegetation and its effect as a barrier fades with increased flow depth. For the non-vegetation zone, this change may be related due to the fact that the flow-vegetation interaction is not the same for the 3 cases due to the effect of the different surfaces projected around the flow as a result of the different distribution of the cylinders that represent the vegetation. To sum up, I came across to these results. The presence of vegetation alternates the flow velocity in 2 forms, variable in the vegetation area and invariable, almost invariable over the vegetation zone. There is a link between these velocity changes and the distribution in the space or the length of the vegetation. Variations in the turbulence kinetic energy, especially in the vegetation zone, increase the turbulence. More turbulence means more loss of the energy, resulting in slowing down the velocity. Vegetation also affects the flow resistance and is one of its sources. I would like to summarize the contribution of this work. They are mostly related to a 3D CFD approach is proposed step by step. This approach shows how the CFD potential as a tool to predict the additional resistance due to the presence of submerged vegetation. Recall that the flow resistance is a parameter that is used to measure the water level in open channels as it is directly related to the velocity. Why not a methodology is proposed that will help on studies to improve the flow stability or forecast in case of large control. There are also several interesting areas for future work. They are mostly related to 2 aspects. The first one, it is related to the modeling of the vegetation under realistic conditions in terms of the form of the vegetation in nature. This will determine more precisely how the vegetation behaves or how it interacts with the flow. So the simulation would be closer to reality. And the second one, it is related with a real case study. So this would be more to measure how valuable this CFD approach could be to a concrete situation where the present submerged vegetation should be removed or not. The first task in this case is the determination of the resistance of the flow, and this CFD model helps. Finally, I would like to thank you for your attention. Also, I would like to thank my Professor Miriam for her guidance and will to make me further the things. Thank you for attending today and hope that you enjoyed my presentation.
Thank you, Izet. You have done a very good
Thank you.
work.
Thank
If
you.
somebody have any question about this topic and about this specific work, research work that Izet has performed? Somebody from the audience? No. Okay, this is, thank you, Izet, once again, and this was the last presentation. But before we go in the wrap-up for this first day conference, I would like to give the floor to Mr. Luga. Please, Mr. Luga, the floor is yours.
So thank you everyone for being with us today. I think it was a very fruitful day for all of us. We had about 10 presentations and 3 keynote speakers, which, as far as I could understand, they were very interesting, all the topics, and also I saw that the audience also was interested by making questions and so. So I hope we will be also together by tomorrow to continue with the 3rd and 4th sessions of the conference. I hope you enjoyed today's presentation, and we will see again tomorrow in the same by logging in the same link. Thank you, everyone. Have a nice afternoon.
There's something on the side.